Hi guys, my name is Ethan Oss and today I'll be demonstrating my ENME351 project. So my project, I made a automatic chicken feeder. I have chickens back home, so having an automatic one would really ease the process. So this is something I might actually use in real life. So basically all I did was I made a tripod stand, that way it could stand better in the dirt. It'd be easier to balance. I just have a simple bucket here where I'll load all the feed into. And then I have just a PVC tube that's coming down here. And I have this hatch automated by a servo. Now the amount of time that the hatch opens will determine how much food comes out. And that amount of time is controlled by this potentiometer here. So there's 4 different settings. So as I turn it, it'll have a smallest to biggest portion setting. So I'll demonstrate it here for you guys now. Load the food in. It's done uploading. Right now the timer's set to every 10 seconds. So it should be about 5 seconds now. And it'll just keep going. Hatch should open for only about half a second. That's the smallest amount of open time. And now I'm going to adjust it. It's kind of hard to see because it goes in half-second increments, but at the full setting, hatch should open for about 2 seconds total. And you can see it opened a lot longer there after I adjusted the servo. You can see it should do it again. Now for the processing portion of my code, here's how that works. So the processing basically takes the input of the output of the Arduino code, which is a string based on the portion size. So it's either skinny, normal, fat, or chonky if you're doing a really big portion size. It'll basically take that and upload an image based on that output of the potentiometer. So right now it's on the skinny setting. And let's run that. So it uploads a picture of a very skinny chicken, lets you know that the portion size is very small. And now if I change the potentiometer setting, we'll go all the way to the chonky setting. Now it should upload a picture of a really fat chicken. There we go. If I adjust it a little bit, I'm gonna make sure it's enough. It should either be on the normal or fat setting. So if I run it again, it should work fine. So this is the fat setting. You can see it's still quite a rather large chicken. And if I adjust it again, don't believe it's on the skinny setting. It could be. Should be a picture of a normal chicken. We'll see. Yep, normal size chicken. So this is the normal feed setting. So now to share my Arduino and processing code. So basically the Arduino is just using the same servo code as we developed during the servo lab in class. So the short pulse and long pulse ranges, those are what I determined from the previous lab. Pulse cycle, 20,000 microseconds. Here I am mapping that angle to the pulses. And then here I define the time between feedings, which is just 10 seconds, basically the time between when the hatch opens and closes. Here I output different strings based on what the potentiometer setting is. You can see that down here, the if statements. And those will also determine the amount of time the hatch is open, which determines how much food comes out. So here I open it if the amount of time has passed, which is 10 seconds. And if it hasn't, it stays closed. And it'll stay open, it'll delay for that amount of time specified, wherever the potentiometer is at, and then it'll go back to close, and then I reset that start time. And for processing, basically, I just have a bunch of if statements that output or display a certain image based on the string output from the serial port of the Arduino. So if the string is skinny, it'll upload the designated picture of a skinny chicken, and same thing for the other feed settings.